Welcome back. We're going to look at Lesson 3.2 Notes, Conditionals, and their related statements. We learned that conditionals, or if-then statements, have a hypothesis and conclusion. They can be written using the following notation: P, arrow, Q, or if P, then Q, or P implies Q. Sometimes we talk about the opposite meaning of a statement called the negation of statement. This is how we write the notation for negation. We write a squiggly line that looks like this. It's the tilde sign that you see on your keyboard, and then a P right after that. This means not P. It negates the whole meaning of a statement. So we talked about negation. Let's take a look at an example here. Here's a statement. It is going to rain today. If I negate this statement, I would say it is not going to rain today. Now, what if you're given this statement here? It is not going to rain today, and you're being asked to negate it. Well, I would write this. I will say it is going to rain today. Let's go ahead and do some more examples. Write the negation for the following statements. Number 1, the sky is cloudy today. So I will say the sky is not cloudy today. Number 2, triangles have 3 angles. So let's go ahead and negate number 2. I would say triangles do not have 3 angles. So we can see that number 1 and number 2, when I negated both of those statements, the sentences include the word not. However, if we look at this statement over here, it is not going to rain today. If I negate that, well, negating a sentence with the word not just removes the word not. So the negation for that would be, it is going to rain today. And that's my answer for that one, okay? Some statements are based on a given statement. These are called related statements. The conditional statement is always in the form if P, then Q, which we talked about in 3.1. The converse is the statement formed by exchanging the hypothesis and conclusion. The hypothesis is always P, and the conclusion is Q. All I need to do, if I'm writing the converse, is just exchange the hypothesis and conclusion. And that would look like this. If Q, then P. The inverse is the statement formed negating the hypothesis and conclusion. So remember, the hypothesis is P and the conclusion is Q. All I need to do here is negate the P and the Q. So this would be not P, then not Q. The contrapositive is a statement formed by both exchanging and negating the hypothesis and conclusion. So we know that the hypothesis is P and the conclusion is Q. I'm going to exchange the P and the Q, then negate those two values. So it should look like this. Not Q, then not P. Number 1, write the converse, inverse, and contrapositive of each statement. If you live in Austin, then you live in Texas. Now, what I would like to do here is underline my hypothesis and conclusion. You live in Austin is my hypothesis, which I will underline once and call that P. You live in Texas is my conclusion. I will underline twice and call that Q. So if you live in Austin, then you live in Texas is an example of a conditional statement. Now the question here is the conditional statement true or false? If false, I will provide a counterexample. Now recall in 3.1 we had a diagram where circle P was inside of circle Q. And we had Austin for P and Texas for Q. I like to think of this as a diagram where the bigger circle contains all the cities that we know and love, such as Austin, Dallas, San Antonio, El Paso, etc. So back to my question, if you live in Austin, does it imply that you live in Texas? Yes. So I will put true here. Now that we figured out the conditional statement, let's write the converse of that statement. Now remember, the converse is if Q, then P. So if the converse is if Q, then P, then all I need to do is exchange the hypothesis and conclusion. So I would say, if you live in Texas, then you live in Austin. So let's take a look at the statement right here. This is the sentence that we wrote. Is this statement true or false? So if you live in Texas, does it imply that you live in Austin? No, because my counterexample would be I could live in Houston. And this is a very specific counterexample. So the answer is false. Let's look at the inverse together here. The inverse, if we recall, is not P, then not Q. All I need to do is negate the hypothesis and conclusion. So again, it's not P, then not Q. So the inverse of the statement would be, if you do not live in Austin, then you do not live in Texas. Now let's take a look at the sentence here. If you do not live in Austin, then you do not live in Texas. Is that true or false? Well, if you do not live in Austin, does it imply that you do not live in Texas? Well, just because I don't live in Austin does not mean I live in Texas. That's because I could be in San Antonio, or I could live in San Antonio. And again, this is a very specific counterexample. So that means that this statement here is false. Now we're going to look at the contrapositive. The contrapositive is a statement formed by both exchanging and negating the hypothesis and conclusion. So it would be not Q, then not P. So the contrapositive of this statement would be, if you do not live in Texas, then you do not live in Austin. Well, is it true or false? If you do not live in Texas, then you do not live in Austin. Well, if you don't live in Texas, then you don't live in Austin, San Antonio, Dallas, etc., right? So I'm going to say true for this one. All right, to the back side. Number 2, if an angle measures 30 degrees, then it is acute. So this is my hypothesis. The angle that measures 30 degrees is my P. It is acute will be my conclusion, which I will underline twice here, and that's going to be my Q. So if an angle measures 30 degrees, then it is acute is an example of a conditional statement. The question here is, if an angle measures 30 degrees, then it is acute. Is that true or false? Well, if an angle measures 30 degrees, does it imply acute? Yes. So the conditional statement here is true, so I don't necessarily need to provide a counter example because it's not false. The converse would be if Q, then P. So I'm going to write, if an angle is acute, then its measure is 30 degrees. So let's take a look at the converse statement. If an angle is acute, then it measures 30 degrees. Is that true or false? Well, it's false because if an angle is acute, then its angle must be less than 90 degrees. It doesn't necessarily mean it's strictly 30 degrees because I can provide a counter example here. I can say 25 degrees because it's less than 90 degrees, right? So I can say 25 degrees as my counter example, and this is a very specific counter example to disprove that statement. Now, let's take a look at the inverse. That's going to be not P, then not Q. So I would say if an angle does not measure 30 degrees, then it is not acute. Now let's take a look at the inverse statement here that I wrote. If an angle does not measure 30 degrees, then it is not acute. Well, if an angle does not measure 30 degrees, does it strictly mean it's not acute? Well, think about it. We can actually say 25 degrees, right? It's not 30 degrees, but it doesn't mean it's not acute. 25 degrees is acute, right? So I can go ahead and say that this is a false statement. And I provided a counterexample here, 25 degrees being a specific counterexample to disprove this inverse statement here. Lastly, we have the contrapositive. The contrapositive is not Q, not P. So if I'm writing this, I would say if an angle is not acute, then it does not measure 30 degrees. So here we go. Is the contrapositive statement true or false? If an angle is not acute, does it imply that it's not 30 degrees? That is true. So if an angle is not acute, which I can assume, then of course you cannot have an angle that is less than 90 degrees here. So I don't need to provide a counterexample. Now I want you to look at 1 and 2 again, specifically their truth values. Look at this and look at this and take a moment to see what you realize here. What I want you to understand from this is that the conditional and the contrapositive will always have the same truth value. That also applies to the converse and inverse. For example, if the conditional statement is true for number 1, then the contrapositive statement is also true. And that works the other direction. If the contrapositive is true, then the conditional statement is true. And looking at number 1 again, if the converse is false, then the inverse is false. Or if the inverse is false, the converse is false. So let me go ahead and connect everything. So we said that the conditional statement and the contrapositive both share the same truth value. And the converse and the inverse share the same truth value as well. So let's take a look at the bottom. So the conditional statement and the contrapositive share the same truth value, and the converse and the inverse share the same truth value. Now let me go ahead and clear a misconception. What if the conditional statement is false instead of true? What do you say the truth value is for the contrapositive if the conditional is false? Well, if the conditional is false, then we say that the contrapositive is false. If the converse is true instead of false, then the inverse is also true. One more time, let's take a look at number 2 again. If the contrapositive is false, not true, then what can you tell me about the conditional statement? Is it true or false? Well, again, the conditional and the contrapositive share the same truth value. So if the contrapositive is false for this statement, then the conditional is false as well. If the inverse is true, what do you say about the converse? Well, it's also true. But yes, I totally get it. You can see it's true here, false there, and true here. So if the conditional is true, the contrapositive is true. If the converse is false, the inverse is false, and vice versa. Okay? So if this is false, this is false. If this is true, this is true. Okay, so I wrote all of this down, so you should do that too on your paper. Now, real quickly, I just want to ask you if it's possible for the conditional and the related statements be all true or all false. Is that possible? Yes, that can be possible. And what I mean by that is if you're given a statement and if this is true, 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 and true, that can happen. Or if this is false, 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 and false, yes, that can happen as well. So I just wanted you to keep that in mind.